Hi everybody. Hi. Okay, so now we're going to talk about exponential, because I didn't spell it right, exponential decay. Let's pretend that I didn't do that. Okay, so here's the deal. This really works well with radioactive stuff and things with a half-life. It doesn't have to be radioactive, but that tends to work really easily for these problems. But it could also be, if you take a medication, how long does that stay in your body? And obviously everybody's different because of your metabolism, but you can get an average. So you know how much medication, anesthesiologists would certainly be very aware of how this decays in the body, goes through your system and goes out in your urine or your sweat or your breath or whatever. Okay. So remember with radioactive stuff or anything, a half-life is how long it takes until half as much remains. Now this is the tricky part for students. It doesn't matter what the A sub naught is. Here's why it doesn't matter, okay? If I say, just for the sake, we'll get to this problem in a second, but if I say, just for the sake of argument, say I have 20 grams of something in the beginning, say my A sub naught is 20 grams, okay? And the half-life, we'll say, is 4 years. Okay, and I want to find how much, let's see, half-life's 4 years. Just leave it like that. Okay, so if I'm using this formula that we have here, okay, if my A sub naught is 20 grams and E to the 4K, say I don't know the rate, okay, half-life is how long it takes until half as much is there. So half of 20 is 10. So the first thing I would do in order to solve for that K is divide everything by 20, which is going to give me 0.5 equals E to the 4K. So if you're solving for something with half-life, it's automatically 0.5. It could have been, if I had, 14 pounds, half of that would be 7, and then I would divide both sides by 14, I get 0.5. So it's always going to be 0.5. So I don't need to know the beginning amount. Okay, so for anything that's a percentage thing, and that's what half-life is, it's how long until half as much is there, so 50%. You don't need an A sub naught. Okay, so let's do this problem. Again, it's a two-parter, okay? So we use this information that it takes 9 months for it to degrade until half as much is there. How much, percentage-wise, would be there in 12 months? So the first part, half-life, is going to be 0.5. That's your half-life amount. Half-life is actually the time it takes. So 0.5 equals E to the 9K. These are really simple. Once you get, comfortable with not having an A sub naught, these are real simple. So again, I'm solving for a variable in an exponential position, which is funky. So I need to move that out front. So I'm going to take the natural log of both sides. And that allows me to bring that 9K out front. And the natural log of E is 1. So I have the natural log of 0.5 divided by 9, and that's going to give me my rate of decay, which is negative 0.077 and change. Now, this should be negative because it's a decay. It's an anti-growth. When you take the natural log or any log of a value between 0 and 1, you're going to get a negative answer, so don't let that throw you. That's what you should expect. Okay, now I use this information to answer the question. Remember, two-parter. So I want to know, well, how much am I going to have after 12 months? What percentage? So A after 12 months of e to the negative 0.00, oops, I'm sorry, 0779. 8.077, sorry, times 9. And that's going to give me 0.5. Something is amiss here. Oh, not 9, I meant 12. I meant 12. My bad. I think I'm more nervous doing this than I am teaching in person. You can probably tell. Okay, so this gives me 0.397 or 39.7%. Okay, so it takes 9 months until there's 50% of the substance left, and it's going to take 12 months until there's 39.7% left. Okay. Let's do another example. Let's say it takes 10 hours Okay, so if it takes 10 hours for a drug to have 20% in the blood, in your bloodstream, what is the half-life of whatever that drug is? This is actually the kind of stuff that's used for drug testing. So, you know, they can tell, or if they draw blood to test for alcohol, if you've been involved in a car accident or something like that, they can tell how long has it been since you had your last couple of drinks. Sometimes, you know, you still have blood in your alcohol in your bloodstream, and you maybe drank the night before. You just think you're hungover, but you're still intoxicated. But they can tell, okay, this person didn't realize, whatever, that kind of stuff. Okay, so a two-parter. So we're going to use this information to find out the rate of decay or the rate of metabolism, and then we'll use that to answer the question. Okay, so 20%, so that's 0.2, e to the 10k. Now remember, with the e stuff, the unit of time that's given in the problem is the one that you're going to have for your answer, unlike that periodic compounding where it's all years. Okay, so this is old, easy stuff now, right? Take the natural log of both sides so we can get that k out to the front. So natural log of 0.2, which is going to be a negative value, because it's between 0 and 1. Okay, so now I bring my 10k out front, and I have my natural log of e, which equals 1. So just going to divide both sides by 10. So natural log of 0.2 divided by 10. Okay, so that gives me k is equal to negative 0.16. Close enough. Okay, remember it's a decay, so negative is good. All right, so now to answer the question, what is the half-life? In other words, how long until there's half as much in there? Remember, half-life is the time unit. So half as much is 0.5. My rate is negative 0.16, and t is my unknown. Solving for half-life, that means I'm solving for time. Okay, natural log of both sides. Isn't this slick? Okay, natural log e to the negative 0.16t. So it's a natural log of 0.5. Bring this out front. Negative 0.16t ln of e, which equals 1. So divide by both sides by negative 0.16. Now this is because 0.5 is between 0 and 1. This will be negative over a negative. It'll give me a positive, which is what you want because we're solving for time. Time is always going to be a positive. I don't know. It feels a little bit like a negative right now. Okay. So T is going to be 4.3. And then you go back up, say, what unit of time? Oh, hours. Okay, hours. And there's your answer. Okay. So I think you're armed enough to tackle the problems on that sheet on CourseWeb. So I want you to try and do those. And the next video that I post, I'm going to go over those problems. So you want to make sure that you try them yourself so that you get some kind of understanding. This is so hard. It's hard for me, but I can't imagine what you guys are having to do. But anyway, I still am not sure if I made the best decision by using YouTube, but my feeling was I wanted it to be there so you could view it on whatever device and whenever you have time, rather than to have a live thing, because your lives are upended, your parents' lives are upended. So, you know, I thought maybe this would be the least stressful way. Plus, I really wanted it to be familiar, even though I'm in my bedroom. So, you know, that's why I'm using a whiteboard and I got markers on my hands. So now I actually have a reason to wash my hands. I haven't left the house in days, but I still wash my hands like 20 seconds, singing a happy birthday. So that's what I'm doing. Anyway, I love you guys very much. You can always text me, okay, or email me if you have questions. So maybe later on in the semester or something we can Zoom or Skype or something like that. But first I have to figure out how to do it. Damn it. Okay. Godspeed. Okay then. Wait, I said stop.